Okay, welcome back. Ladies and gentlemen, 5.5, Law of Sines. I'm going to be breaking this into two separate videos, the first one being the easy half and the second one being the harder half. But we'll make do. All right, so first things first, I want to kind of tell you what we're doing here in 5.5 and 5.6. We're going to use the law of sines and what eventually will be the law of cosines as well. Solving triangles, but really solving real-world problems. And you might have figured this out if you thought about it. Real world doesn't always exist in right triangles. So what we want to do is we want to be able to solve any type of triangle even if it's not a right triangle. So we'll get outside of right triangles and really real world. But let's first do some geometry. And I'm sure every single one of you just said, yay, I love geometry. All right, so what we're going to start with a basic triangle looking like a little bit something like this. This is not a right triangle, but we're going to label it certain values here. And this little side, this long side here is C, this is little a, this is little b. And of course, triangles, we like heights. And a height of a triangle is always the triangle, the length here that's a right angle to the base. Or called the altitude, by the way. All right. Now, we are looking at triangle ABC. But what I want you to do is I want you to, let's say this. Let's write H. Write H. Let's see, how do I want to word this? Write an expression for H. In terms of A, angle A. And I know obviously you might not do this, you might wait for just me to do it, but think about it. If you're looking at side H and angle A, remember we're in trigonometry, and trigonometry says we can write ratio of sides using trigonometric functions. Now, because C is this whole length, I don't know what this length from A to this right angle is. But I do know H and B. And if I look at this, that means that I can look at the sine of angle A is equal to the opposite side, which is H, over little b. But because I want an expression for H, that means I need to get H by itself. So we're going to say that H is equal to B times the sine of A. Now this is actually a little expression that we're going to use later. The fact that the height of a triangle is this hypotenuse looking thing times the sine of this angle. This is very important to us. But now this doesn't really get to where I'm going yet until I say, okay, let's write an expression for H. Let's do it instead of angle A. Let's do it for angle B. And so I can do the same thing as I just did. I could say, well, this is actually the sine of B is equal to H over A. So looking at this right triangle on the right, sine of B is equal to H over A. And again, I could say H is sine of, is A times the sine of B. Now, what's very interesting here is H is equal to this statement, but H is also equal to this statement. And by our property of transitivity, remember we're doing geometry, our property of transitivity says that those two things are equal. Oops. And I'm going to do a little bit something weird here that you might not have thought to do. I'm going to divide this side by A, which means I got to divide this side by A. And I'm going to divide this side by B, so I'm going to divide this side by B. And I get this very nice little expression saying the sine of A over A is equal to the sine of B over B. Notice here the A's canceled and here the B's canceled. Well, I didn't tell you what we were doing, but we were actually creating the law of sines. This is actually part of the law of sines, so I'm going to move into the law of sines itself. So the law of sines basically states this. The ratio of the sine of an angle to the length of the opposite side is the same for all three angles of any triangle. And I am going to stress this word, any triangle. Any triangle. So I don't have anything to do with right triangles in here. I can do anything. And so we have that sine of A over A equals sine of B over B. But I can extend this into the sine of C, and this is for all three angles. Now, this particular way that this equation is written, it doesn't matter what two fractions that you use. If I don't know anything about C, I'm not going to use it. And I can solve for things here. But notice what you're going to need to be given here. I have four variables, big A, little a, big B, little b. You're going to need to be given three of these things in order to solve for the fourth. Again, if I don't know anything about B, I'm not going to use this fraction B. I'm not going to set up three equations equal to each other, three fractions. I'm just going to set up two fractions and use proportions. Now, oops. This particular equation is good for a very specific reason. This particular one is good to find angles because the angle is in the numerator. And it's just nice and easy. You just have to multiply by A to both sides. So notice if I did that, let's say I had sine of A over A equals sine of B over B. If I wanted to solve for angle A here, I would multiply both sides by A. So I would get sine of A equals A sine of B over little b. And then if I need to solve for A, now we need to remember how to get rid of sine. And in order to get rid of sine, we use sine inverse. So A is equal to the sine inverse of this fraction here. Okay? Now, there's a slightly, the other, you might have seen it just a second ago kind of flip up there. But the other variation is just finding the reciprocal of all of them. And this particular version is good to find sides. Good to find side lengths. Only because, again, same thing. If I had A over sine of A equals B over sine of B, in order to solve for A here, all I have to do is multiply by sine of A. So I'd say little a is equal to B sine of A over sine of B. Nice and simple. Now, the law of sines only works for very, very specific types of triangles. Now, not by like right triangle, oblique triangle, scalene. That's not what I mean. But what are you going to be needing to have? What is going to have to be given to you? So if I had A, B, C, let me get rid of those letters there. What if I was to say this was 30 degrees, this is 6, and this is 4? Could you use the law of sines here to solve for anything, really? The answer is yes. I would say the sine of 30 over 6 is equal to the sine of x, which is this, over 4, which means this is an okay triangle. And if you remember your geometry, and you remember your congruency theorems, this is angle, side, side. So, or side, side, angle. Now, I remember that one wasn't very nice. And that's actually going to be our second video. That's the piece that we're going to look at in our second video. What about, let me get rid of some of this stuff here. What about, let's change what we were given. Oops, I didn't want to delete my triangle. Oh well. Let's try another triangle here. And let's say this is 30 again. And let's say this is 6 and this is 4. Could I use the law of sines to solve anything from this triangle? Well, the answer is no, because if I tried to set up sine of 30 over what? Little a. Now, I don't know what little a is, and please don't use the Pythagorean theorem, because it's not a right triangle. Okay? I don't know what a is. Okay, well, maybe it's solving for an angle. Well, now I don't know what, if this is b, big B, not a 13, sine of big B over 6. Same thing goes for the other angle. That means I cannot use, what is this one? This one would be side angle side. So side angle side is a no-go. So that one doesn't work. What else could we use here? I already did side angle. So let's think about what our options are. If you remember from geometry, we had things like side angle side, side angle angle, angle side angle, angle side side. What else? Angle angle side is the same thing as side angle angle. What else do we have here? Oh, the other two versions that we're not actually going to deal with, or actually we are. Angle, 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 and side, side, side. I think that was all our variations. So we already said that this version works. We already said that this version doesn't work. So the question is, what else will work? There's actually two more that will work here. And let's just think about the first one, side angle angle. What would happen if I had side angle angle? Side angle, let's say this is, I don't know, 25 degrees. Well, sine of 25 over 6 equals sine of 30 over this. That means side angle angle is a good one. What about angle side angle? What about angle side angle here? Let's delete this. So angle side angle, let's put the 25 right here. But some of you are like thinking, well, I can't do that because sine of 30 over blank is equal to sine of 25 over blank. But you do know that you have two angles and you can find the third angle. So technically you can use law of sines here. So this is 55. So 125 degrees is here, which means now you can set up law of sines. So angle side angle works. And let's get rid of this side here. Let's say we had the angle, angle, angle. Well, since the ratio requires two sides, or at least one side, I can't do this. So angle, angle, angle doesn't work. And side, 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 same reasoning. I need an angle, so side, side, side doesn't work. And you might guess where we're going to use those other three. Those other three are probably going to come in tomorrow's video for the law of cosine. Now, the ASS or the SSA version, this gets a double star because we're going to come back to that a little bit later. Now, I know I went the long route around here, but for the most part, what you need to know is if you're given angle, angle, side, or side, angle, angle, however you want like to read this one, angle side angle or angle side side, you can use the law of sines. So let's use the law of sines. You're given a right, or not a right triangle, you're given a triangle. And you're given this is 36, this is 48, you're given this is 8. And you're needing to solve a triangle, which means you need to tell me what everything else is. Now, this angle here is easy to find. And you do have to look. I mean, this is angle side, so it's legal to use law of sines. So this is 70, 84. So you're looking at 180 minus 36 minus 48 is equal to 180 minus 84, which is 96 degrees. So this angle here is 96 degrees. Easy, done. We're 1 out of 3. Now we just have to look at the other pieces. Since I'm looking for sides, I like the other version here. Let's call this, let's call that big C. That's B, that's A. So little b over sine of 48 equals 8 over sine 36. I can multiply both sides by the sine of 48. So b equals 8 sine of 48 over sine of 36. And I hope you guys have been paying attention for the last, I don't know, month or so. This is 48 degrees, so you better be in degree mode. So I'm changing my calculator to degree mode. And I'm going to say 8 times the sine of 48 divided by sine of 36. And I get b is approximately equal to 10.11. And there we go. Now, when you go to find little c, don't use 10.11. So this is one of those areas. You can if you use it as a stored value. But because it's an approximate, I don't want to use it. I'm just going to reset this up with c over the sine of 96 equals 8 over the sine of 36. And I'm just going to do the same thing. So little c is 8 sine of 96 over sine of 36. You notice the process is actually pretty repetitive. So you can basically take whatever you had to begin with and change the 48 into a 96. And you get something along the lines of 13.54. All right, so these ones are pretty easy when you're given a triangle and you're given certain pieces and you just label it and find the other sides. The hard part obviously comes when you're asked to do a real world example. And I just heard every single one of you just groan right now. You all groan that loudly. All right, so here's what you have. You have a road that slopes 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees, and the pole casts a 14.5-foot shadow downhill along the road. You need to find the height of the pole. Now what I want you to do is I want you to pause the video right here, and I want you to draw the picture that is involved here. Because I want you to be able to draw this picture. Okay, now I'm going to draw mine. I know the assignment changed. I meant to put a blank page right here, but whatever. All right, so here you have it. You have a road that slants 10 degrees on the horizontal. That looks like 10. I'm going to use a yellow line for anything I'm talking about horizontal. Okay, so I'm increasing. Sorry about this, don't know what's going on here. All right, let's try this again. Right here is 10 degrees. I also have a telephone pole that stands straight up on this hill. I have a sun out here, and the sun sits way up here. Oops, that's a straight line. I don't want a straight line. Undo. I want a curve. So, an orange sun. I'm getting creative here. All right, you have the sun. It has an angle of elevation. Well, angle of elevation comes from horizontal. So I need a horizontal. And the angle of elevation for this, and this is a fake line, by the way. This line doesn't actually exist. So let's use a light blue here. The angle of elevation is 62 degrees, which is right about here. So it's creating this shadow right down here. Let's use my pen. And it's creating a shadow on the road right there. Now this angle here is 62 degrees. And you know that the shadow length, sorry, I forgot what it was, 14.5. And you need to figure out the height of the telephone pole. So how are we going to go about doing that? It's a good question, Mr. Nelson. Why don't you tell us? Okay. Guess what? I said something about geometry earlier, so it might be a good idea to remember some geometry. Man, this is going to be hard. Where do we go from here? Okay, so what we need to do here is we need to think about this coming straight down, which makes a right angle. There's all sorts of stuff you can do here. Actually, this 62 is also over here. Hey, vertical angle theorem. Nice use of the vertical angle theorem. Well, this is a horizontal line and a vertical line whose angle meet at, or who meet at a 90-degree angle, which means if this is 62, this is 28. And now what? Oh, look, this is 90. But how do I use that? That's a good question. There's all sorts of stuff. I'm going to use this one because this is the one that first comes to me. I have this little triangle down below. This is 90 and 10, which makes this an 80-degree angle, which makes this a 100-degree angle. I don't really care about that angle, but I do care that this is also a 62-degree. Sorry, not 62, a 52. My fault. Okay, 100 plus 28 plus 52. And guess what? Now I have enough information to solve for that height. So x over the sine of 52 equals 14.5 over the sine of 28. Do a little quick math. Multiply both sides by sine of 52. I get x is equal to 14.5 times the sine of 52 divided by sine of 28. I get the height of the telephone pole to be 24.34 feet. See, it's all about being able to visualize. So a lot of the problems in the textbook, they're going to give you pictures and you're going to go from there. But in case you don't, you need to be able to draw pictures from the given information. Okay, so there's the first half of the video. This is obviously the easier part, just basically using law of sines. The next part is going to come up right after this. All right, have fun. I'll see you guys in a couple minutes.